Hello, everyone. Good evening. Dear authors and invited guests, welcome to Technical Session 4A. Myself is Shita Sauryan, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you all to the 9th International Congress on Information and Communication Technology, London, UK. The 9th edition of the conference is being organized in a hybrid mode. The physical event was organized in London, UK on the 19th and 20th of February 2024, and the virtual event is being held through Zoom today and tomorrow, that is 21st and 22nd February 2024. I hope you will all enjoy the knowledgeable and interactive sessions through the day. In this session, we have 6 presentations. Each presenter will be given 12 minutes for the presentation and 2 minutes for question and answer. On 10 minutes, I will raise a gentle reminder. There's another request to all the participants to please stay connected with us till the end of the session. Just before we get started, I would like to introduce you all to the chair for this session. Our session chair, we have with us Dr. James Stephen Meka. Professor James Stephen Meka is a full-time chair professor, Dr. B.R. Ambedkar Chair at Andhra University, and is also serving as Dean, Transdisciplinary Research Hub of Andhra University. He has been in teaching and research for over 20 years. He served as a principal and professor of CSE at WISTM Engineering College, Vishakhapatnam, over 9 years. Dr. James also acts as a mentor of American Corner, Vishakhapatnam, Andhra Pradesh. He has an expert in amalgamating technology with social needs to provide novel solutions. We welcome you, sir.
Yeah, thank you. Thank you for the introduction.
Thank you, sir. We'll be proceeding with the first presenter for the evening. I'd like to invite presenter Marina to present the paper titled Artificial Intelligence in Breast Cancer Diagnosis, SynergyNet and Campania FESR POR Research Project. Ma'am, you may start with your presentation.
Thanks for your presentation. And I can introduce my presentation?
Yeah, sure. Please go ahead.
No, condividi.
Hello?
Yes, sir.
Is the presentation going on?
No, sir, it hasn't started yet. Ma'am is actually connected with the presentation.
Yes, please. Yeah.
Ma'am Marina, if you have no issues, then we can take you up next. If you're having issues with the presentation.
Yeah. If it's possible, I prefer, because in this way I can solve my troubles for condivision of my screen. Okay?
Yeah, sure. We'll take you up next. We'll be moving ahead with our next presenter. I'd like to invite paper presenter R.V. Espanto to present the paper titled Development of Text Reading Camera to Assist the Legally Blind Using Neural Network Image Processing Algorithm. You may start with the presentation.
Let me share my presentation.
Yeah, sure. Please go ahead.
Okay. Good day, everyone. Allow me to present the research entitled Development of Text Reading Camera to Assist Legally Blind Using Neural Network Image Processing Algorithm. My co-authors are Mr. Aaron Mendoza, Mr. Cedric Morland, and Engineer Annabella Doctor. And yours truly, Engineer Ria Espanto, at Lyceum of the Philippines University, Cavite, Philippines. The Commission of Higher Education in the Philippines has issued Memorandum Order Number 46/2012 CMO 2017, which state that the computer engineer program offered in any college or university must have the ability to design computer-based system network that includes both hardware and software, as well as their integration to solve novel engineering problems, subject to trade-off involving a set of completion goals and constraints. The design refers to a level of knowledge that goes beyond assembling, configuring system with the support of engineering professors, as is practiced at the Lyceum of the Philippines, Cavite Campus, Philippines. Vision impairment may be caused by the loss of visual acuity, where the eye does not see objects as clearly as usual. The World Health Organization defines low vision as visual acuity between 2070 and 2400. Visual impairment is also known as legally blind. A person can still see but not clearly. It causes struggle reading, walking, and performing other activities that require vision. This study aims to develop a text reading camera to assist legally blind with the following features. Reading product labels and codes received currency, product package labels, and other object-rich text-related labels. Read American alphabet and numeric numbers, implementation of neural network image processing, visually impaired device using Raspberry Pi, which integrates camera, buttons, and speak as input and output components respectively, and program using Python programming language. Test the performance of the developed device based on its functions. Evaluate the performance of the device using ISO IEC 25010 quality standard. The research design studies use engineering design and quantitative methodology to obtain the essential data. Quantitative research allowed the researcher to gather data of numerical measurable nature and be able to formulate answers and conclusions based on the mentioned data. This study also adopted the principle and characteristic of agile development cycle to aid the proponent's development situation, capabilities, and identifying the detailed requirements of the system. The proponents undergo rigorous plans to achieve the goals of the project that illustrate the flows on how the text reading camera device works as a whole. To initiate the project, the Raspberry Pi have necessary libraries and engine installed to function as desired, which also include the OS of the function code. Once the software initialization is done, the peripheral will be connected the Raspberry Pi designated port. The working principle of Raspberry Pi would be heavily reliant on its software and its ability to process the image. Once the image is captured, it will be saved as PNG file and will be entered into elaborate procedure. OpenCV and Tesseract will solely work for this, including conversion to grayscale, edge detection, removing background, detecting text and its edges to fully identify them. Once the text is extracted, it will only contain the recognized text from the captured image. The text detected will be then set a variable that will be called on the text to the speech process. eSpeak is a speech synthesizer that can convert the contained text in text file into speech. After using PNG and text file, it will be discarded to prevent redundancy of TTS. On the figure shows the physical design of the proposed project. The software part of the subject was developed on the desktop and then implemented on the Raspberry Pi. The prototype of this study was developed in this stage. The whole device worked and functioned as shown in this figure. The dimension of the prototype shown in this figure was ensured by the proponents to have a good ratio of fitting each component and maintain capability to the comfortable when held with hand. The cost worth of the device upon development was 3,900 pesos or around $40, a bit higher compared with the market since the most of the major component must be ordered abroad and bought by per piece. There are two test methods performed by the proponents. First, the functionality of the developed device, where the proponents check the accuracy of the image to voice conversion, how hardware works accordingly, and allowed characters that are registered and interpreted by the device. And second, test the performance efficiency through reliability, usability, and portability criteria, where the proponents perform test drive on varieties of text such as color, font size, length, quantity, and quality of the image. The proponents intended two options where the device is used by the end user for this process. To lend the device to people who are legally blind to fully experience the device and demonstrate how the device works with actual usage to the proponent, which done upon evaluation stage. With the utilization of sampling technique, the proponent determined to seek 25 respondents to evaluate the developed device with 5 criteria, such as functional, suitability, reliability, usability, portability, and performance efficient, which is adapted from ISO IEC 25010. The respondents are composed of 12 normal vision individuals, 9 individuals with visual impairment, and 4 persons considered as legally blind. The evaluation was conducted in different households of the respondents in Cavite, the province in Philippines. The proponents developed both hardware and software application system in this study. On figure 4 shows how the 4 input buttons of the developed prototype are connected to the Raspberry pins. As depicted, all ground side of the button is connected to the single pin ground, while they have their own respective input pins. The camera is also shown to be installed to its respective slot. Furthermore, figure 5 up to 7, 6, and then the next one is 7, shows the actual circuit and prototype developed by the researcher. The software development, we have natural syntax. The proponent gathers data set with 400 image of sign, billboard, company logos, and other manual scenes. To perform the training, the images were compiled to one file. Once command executed, the result of this display as shown in figure 7 and figure 8. So we have a receipt text. The approach used for creating trained data varied on the receipt phone. This training is much easier as it's required to no manual correction of bounding boxes within the image. Rather, it's utilized and already image trained data file as the reference. The software side of the system are built using Python programming language and Raspberry Pi. Python used for the hardware part to function as requirements. The Raspbian OS used as a channel for the hardware and software to work together. The system works in the way that is utilized two methods. 4-point transformation, the is-text detection, extracting the text from the image by itself without undergoing any processing. The third method is only helpful on very ideal image which do not exist in the natural environment. 4-point transformation acts similarly to scanner. Hence, this method is desired to be used on images that have subject of hard copy of printed documents. The way it works is finding contours.
Ma'am, I'm really sorry to disturb you, but I'd just like to remind you of the time limit.
Yeah.
Yeah.
Okay, then the is text. So this is the testing process that we are conducting. It shows on the figure. So we have a different trials about approximation of accuracy test result. And then the reliability test results, approximation of accurate evaluation result based on ISO 25010. Okay. The conclusion, the proponent successfully created and built a camera based with the application of neural network image processing algorithm to assist legally blind individual and partially sighted or low vision in reading text labels. The utilization of network algorithm enables the developed device to be used on natural environment. It is also concluded that despite the developed prototype is being functional as intended, the reliability seems to cool down its function and improvement of this device is destined to be conducted for optimum utilization. It is concluded that the use of more high-end hardware materials and components are highly needed and more allotted time given to focus on the development. Some major challenges encountered by us during development are problems in taking the input or capturing the image, as many parameters as needed to be considered from the image from natural environment can be improved by simply using better hardware like the latest Raspberry Pi or any better microprocessor and optimizing utilized libraries to the latest. That's all. Thank you so much.
Yeah, thank you. Any questions from the participants? No questions? Yeah. Then we go to the next participant, but the point I request to the remaining presenters, please spend more time on your contribution instead of spending more time on the introduction part and the other things. Focus more on your contribution so that other participants would get enriched with the contributions, what you made in your research. Thank you. So finally, one question, what is the future scope of your research?
The reading cameras, or this one is these algorithms are trained in massive data sets of image and text enabling to recognize object characters seen with high accuracy in the context of reading camera. This algorithm can use as the exact text from physical documents and digital screen, recognize object and provide description, navigate unfamiliar spaces. While still under development, reading cameras powered by neural network offer significant potential to improve independence, mobility, and access to information for people who are legally blind.
Good. Is the background your college?
Yes. Yes, sir.
Good. We can go to the next presenter, please.
Thank you, sir.
Thank you, sir. Thank you, ma'am.
The more.
Ma'am Marina, if you're ready, then you can start with your presentation. Since she had a connectivity issue, we'll be proceeding with the next presenter till then. I'd like to invite our next presenter, Thomas, to present the paper titled Distribution-Specific Augmentation for Domain Generalization. So if you're here, then you can start with your presentation.
Yes, I can start, but I just need to share my screen.
Yeah, sure.
Okay. Yeah, so hello and welcome to my talk about distribution-specific augmentation for domain generalization. My name is Thomas, and this is a work collaboration with Lukas Schmidt and Klaus Obermeier. Deep learning methods are achieving impressive performance in various numbers of tasks and are somehow often linked to the functioning of the human brain. However, despite their success, it still faces challenges when it comes to generalization. And of course, it doesn't match the possibility of adaptation and robust adaptation of human intelligence. One key limitation is basically distribution shift, where basically the training and test data comes from different distributions. This strongly impacts the model performance, and it's an open question in machine learning still. And this can cause problems in safety critical domains like autonomous driving or healthcare. So what's distribution shift? Basically, it refers to the change of the training distribution and the test distribution. And a common statistical measure to quantify it is the KL divergence. We somehow try to measure the divergence between two distributions. Also in statistics, various methods are used, such as the Kolmogorov-Smirnov test or Wasserstein distance, where we measure the minimum cost of transforming one distribution into another one. And addressing this shift, there are several research directions. For example, domain adaptation, where models are adapted from the source to the target domain, or transfer learning, where knowledge from a related domain is transferred to improve performance on the target domain. So this is an example. On the left, we see basically two source domains, and the domain is different. And so they actually have a different decision boundaries in these two domains. And in the test domain, we actually have another domain, another domain, and we somehow have to transfer the decision boundary. Here's, for example, 6 images from the iWorld CAM dataset, where we basically see the domain. Basically the background builds the domain, in the foreground the objects which have to be classified. And this is one of the benchmark datasets in this area. So what's the formal definition of domain generalization? We basically have a dataset. A domain actually consists of a dataset of X and Y, following some distribution. And then the training data is basically a union of several domains. And then the test data is a union of other domains which don't overlap in distribution. And then we want to learn a classifier which somehow has a minimum error on the t-test. And for our approach, we now expand this notation by decomposing the background and the foreground of the image. So this results in the formula ds, where we basically have a data set which doesn't consist of tuple with X and Y, but now we have L, S, and Y, and L stands for the background and S basically for the foreground of the image. And S is consistent across all domains, while L is the same inside a domain. So that's the background, which should be the same for every image. But and S is the object, which should be consistent across domains, like lion, for example, should be the same or similar. And now what our idea is that we augment a data set such that we basically add distribution specific samples to our trained data set. And the idea is that this classifier then is better than the standard classifier. So we have a detrained data set where we have the normal data set, and also DS as data set, where we only put the foreground, which we extract from the image into our data set. So the foreground of S is used as input for the neural network, whereas the background is disregarded. And how do we decompose all the images? So we do background modeling by using RPCA, which is solved by principal component pursuit. And this approach basically decomposes a matrix A into a lower rank matrix L, which can be named principal components, and the sparse matrix S, which are the outliers. Each applying this, each batch includes exactly one domain. And the idea is that we basically separate the class relevant foreground from the rest, and we somehow treat them as outliers. And the similar background somehow is like the other low rank matrix are the principal components. And here we have for our synthetic data set an example. So on the left, we basically see the original data set, and here this is basically what is instructed. That's like the background, that's the foreground. That's somehow the result of the application of RPCA. I think I skipped this slide. It's just the background how RPCA basically works. So our synthetic data set, how is it? How do we create it? So we have basically a noisy distribution modeling the background, and object-specific distribution with geometric shapes, which model the foreground. And grayscale images with Gaussian noise. And in each domain, in each split, has the same Gaussian noise background. So this is how our dataset is composed. We have different basically distributions, and then train we have the same data, and then test not anymore. And then this is basically our example. We have already seen it before. And now if we apply this on a real world data set, the ICICT Camp 2020 data set, we have different challenges to tackle, like a variable amount of images per domain. And if it's only 3, it's difficult for RPCA, so we have to investigate a minimal viable batch size. And here in the first example, we actually see we basically increase the batch size from domains where we have a lot of data, and we see that by increasing the batch size, actually the contours of the foreground is more clear than if we only do like 10 approaches. We see it especially in the first row, but also in the other rows. We see that we get better if we can increase the batch size. Although this is only possible if we have this available. Another problem is are the RGB values of images. So what we basically see is that images of the same class depict in different, basically result in different base colors, because this is somehow the foreground, and it somehow is a side effect which we still have to tackle. So it's not solved yet, such that the color is different, although the class is the same, and this is not optimal, because this is somehow what we want to basically remove the background fully and not have a relict there. Okay. So now we come into the results. We have our classification experiments. We apply ResNet on our synthetic data set, and apply a larger ResNet model on our ICICT Camp data set. You use decay learning rate, and after we have we train it on GPU, and we have 2 evaluation matrix, accuracy, but more important, the macro F1 score, which is somehow a weighted approach of the micro F1 score, which counts the F1 score across all the data set, but we do it for each class separately, and then we average it together. This is the performance on our test on our synthetic data set. Here we see the data set where we train on, and here where we test on. And we first of all train only on the sparse data set, and then also we test. Yeah.
Really sorry to disturb
Yeah.
you, but I'd like to remind you of the time limit.
Yeah. I have, okay, one minute left. Okay, but it's fine. Okay. So we have the train data set, DS, and we have a test data set. We also test on this somehow in foreground, which is somehow unfair, but of course it works best. But what we see here is that, if we train it and test it on the normal data set, we only have a macro score of 52. But if we then extend it with our approach, then we get accuracy of 95%, which is really good in our synthetic data set. Of course, our synthetic data set was proposed to work well on this. So this is the performance on iWild's CAM dataset. Here we see sorry, that's the wrong slide. So I think to get it somewhere else. Yeah. But so the problem is, like you can read in the paper, that the performance on the iWild's dataset, it's only working slightly better, but not really much better. So coming to our conclusion, we introduced the distribution-specific augmentation, DSAG, and it worked quite well on our dataset, on our synthetic dataset, but only showed a slight, only showed a little improvement on the iWild CAM dataset. And we proposed already some challenges which we still have to tackle on. And so we have also some ideas for future research, like using an autoencoder as an intermediate layer. And yes, this is it. Thanks for listening to the talk.
Yeah, good. So any discussions or questions from the participants? No? Yeah, the presenter, I have a question. Like, you tried RGB in your work. Did you try the other side of CMY?
CMY, no, we only tried PCA. But CMI, it's actually a good idea. Maybe I write it down such that I can elaborate on it.
Yeah, you can always do
have-
that CMY. There you can add even K for black, and you can try your results with that. Yeah, you can extend the work to that.
That's a good idea. But basically, this approach in general is actually interchangeable. So of course, it doesn't matter which approach we use, but the it depends on the overall idea of
Great, thank you
for this idea.
Yeah.
Thank you a lot. And
Thank you, sir.
Yeah.
Ma'am Marina is ready. Ma'am, you can start with your presentation.
Yeah, thank you. So, good afternoon. I'm Marina Di Domenico from University of Campania, Luigi Vanvitelli. I focused on the crucial role of artificial intelligence in breast cancer diagnosis. I am going to talk about the screening of this oncological disease, and in this outline, I may resume the topics of my work, and in this topic, I propose the translational framework using a convolutional neural network and the prospective implementation of artificial intelligence to improve early diagnosis of this cancer. Breast cancer found its origin and artificial intelligence in proliferative cancer found its origin in the study, in the major work introduced by Ol Kazami, who is a mathematician and astronomer. He was a pioneer of concept of data collecting. So in this slide, I will present the interplay between the collected data set and the available artificial intelligence system. But breast cancer and artificial intelligence are related to due condition. In the past, we had computer eye detection system that were developed to improve cancer detection. The use of a card resulted in increased recalls, more time needed to assess screens and more biopsies without improving cancer detection, conferring no screening benefit. But in the future, using artificial intelligence, we can organize and improve the potential of this screening. And modern artificial intelligence based on deep learning is a different technology from past card system and has demonstrated either potential in supporting the quality of screening services and reducing workload depending on its workflow integration. For breast cancer in epidemiology, in current scientific literature, a new approach for breast cancer disease is represented by contribution of artificial intelligence. Breast cancer screening detects cancer at early stages, leading to a reduction in breast cancer mortality. Although breast screening reduces overall mortality, and this analysis has a limitation that results in failure to detect cancer in a considerable number of screened individuals. So, according to World Health Organization, malignant neoplants are the greatest worldwide burden for women, estimated at 107.8 million. For incidence and mortality, we know that breast cancer is the most commonly diagnosed cancer. We have 24.5% of female total cases. So, otherwise, mortality in women breast cancer is the most commonly diagnosed cancer and the leading cause of cancer death. And this is, we have a 15% of female total cases. But here we have a big number of risk factors, significant. They are significant and they include different risks. We have two categories. We have modified factors and not modified factors, but we know that for non-modified factor, we consider sex, holder's age, family history, genetic mutation, race, pregnancy, and it is important to consider previous radiation therapy for adult neoplasty treatment. For modifiable factors, we have hormonal replacement therapy or alcohol intake, smoking, or other drugs. So for literature and my contribution to literature in the signal transduction growth factor, I consider the effective governance of transcription and cellular adhesion cancer evasion for this type of neoplasia, because steroid hormone and protein targets in signal transduction represent the governance for cancer invasion in breast cancer. But for the second part of the outline, we focus on the oncological disease faced with the SynergyNet project. So the project, our project challenge is to reach the early diagnosis in different neoplasms. Thanks to the partnership of working group members, we have to thank my university, but with the actors from this university, the Bolino as a society for leader and material implementer of the platform, the Chinese National International University Consortium. This consortium proposed the algorithm that regulates the functioning of this platform, and the Campania region, which funds for project. So oncological disease faced with our project, SynergyNet project, collected a lot of different type of cancer: hepatic cancer, gastric cancer, skin cancer, prostate cancer, thyroid cancer, colon, rectum cancer, breast cancer, lung cancer. In the next presentation, I propose the next study on prostate cancer. In this way, we analyze by imaging only, and imaging and the video methods. But here we is depicted a roadmap for which is a roadmap to develop, to describe our Synergy project, and we start with this project with breast cancer research, and in this for this neoplasia we define artificial intelligence as an important consideration to organize the initial decisional tree, to define what we have to do to propose an early diagnosis for this breast cancer. The aim consists in identify a diagnostic path which can be intelligent, that is integrated with the most modern machine learning technologies capable of helping healthcare workers in choosing a diagnostic path personalized therapy for each individual woman. So the aim of this study is added with the study population, and here we consider the number of 115 female patients, 35 with cancer, but we have the different group organized for aging, but in risk factor considered are described on the right of this slide, and we have age, family history, age of the first pregnancy, and is very important consider the hormonal therapy. We add material and methods in these slides. We have mammography, con la mammography and resonance, and we have we consider that for a typology, variance and number, and the extent, different opacity compared to previous exams. We consider density in relation to age, the detection, newly appearing mammographic opacity, and the type of micro calcification detected, and their variation, number, and extension to subset test. But we just arrived at the third part of my presentation, in which I present prospective implementation on artificial intelligence ready to improve early diagnosis for this cancer. Here we propose our results. We know that it's very important to connect it, laboratory medicine together with imaging. we have to consider for in the biological indicator high sensitivity, high specificity, possible early detection. I have
I'm
to.
really sorry to disturb you, but I'd like to remind you of the time limit for the first paper.
Yes, I have the second presentation with
Yeah.
project. Quanto? Yes, I have 2 minutes. Okay, but to conclude my first presentation.
Sure.
Okay, the scientific work carried consists of overlast need big data computing is growing in many disciplines, and the same also applies to oncological research area. Yes, and now we have the conclusions. This work described SynergyNet and a going project aimed at creating a technological platform to support oncological diagnosis based on the integration of interoperable communication and also clinical data manager system that explore artificial intelligence. The first idea is to explore modern ultrasound elastosonography as a low-cost methodology with no side effects, the yearly diagnosis of oncological disease for all tumor types considered in SynergyNet project. The second idea is to provide integrated prevention through data by fusion techniques. The objective is to analyze information from multiple sources in order to provide an integrated tool built on medical knowledge of each specialist. Thanks and we have acknowledgement for working group members and actors, professor and researcher from University of Study of Campania and University of Naples, Federico II. Thanks.
Yeah, that seems to be a very good work. Any questions?
Yes, may I start with the second artificial intelligence in prostate cancer diagnosis?
So you want to continue the next paper?
Yeah, it's a different paper because we have different study. I show my roadmap in a different type of neoplasts. And we start with breast, but we continue with using prostate cancer, lung, and the other neoplasts. So
I think better you go ahead. You go ahead with the other paper also, that we can have some discussion or questions at the end.
It's okay. So in this presentation, I propose my outline, and in this for this type of cancer, I have a different approach, and but the role of artificial intelligence was the artificial intelligence has a crucial role because we use a convolutional neural network in this paper, in this experimental study. So I start with this presentation with a definition of artificial intelligence because I think that is very important to comprise that the capacity intelligence is to be considered the capacity of computers or other machines to exhibit or simulate intelligence behavior. But we do that, and we have an important scheme in which there is a lot of connection, and in the middle we have the early diagnosis, and we are planning surgery, robot surgery, drug discovery, molecular design, and telemedicine. All disciplines links together, but it's very important to know that integration of artificial intelligence in cancer research has revolutionized the field. And the substantial events are in diagnosis, assessment, and intervention. And AEI includes a contribution to machine learning knowledge representation, planning, real-time decision-making. We know that artificial intelligence will encompass a spectrum of technologies. So in this slide, I should like to show this slide because I think that we have the fascinating test titled Artificial Intelligence. Its name is A Modern Approach, a modern by Stewart, a modern approach in artificial intelligence by Stuart Russell and Peter Norvichis. These authors explore the ever-expanding field of artificial intelligence and its latest technologies and methods, considering the ethical aspect and the values of practicing the discipline. So, but here I have put in the middle of this slide Vitruvian man, because Vitruvian man represent the intellect. Vitruvian man represents the intellect because the intellect is a person with knowledge gained through the years, while artificial intelligence involves a plethora of topics and practical applications, offering a deeper understanding and a multi-phased approach to this expanding subject. In this slide, the integration of information leads to a potential integration of practical parts. But we know that artificial intelligence consists of machine learning and deep learning. And it's very important to consider all network like convolutional neural network, which is the base of our project. We know that machine learning techniques comprise supervised learning, unsupervised learning, and deep learning, all techniques, but machine learning algorithms are very connected to cancer research. We know that we have a lot of acronym in this slide, but they are all models that we can adapt to different strategies in the different individuals. So artificial intelligence is connected to One Health. This is the base for to know the causal modeling, and we know that One Health is represented by developing resident social system, target health, surveillance system, and environmental risk. Cancer is the One Health perspective, and we have we know that cancer causing or cancer associated processes cannot be considered in isolation from other biological players in ecosystem. In the second part, we have the translational framework in this cancer, and I presented the same oncological disease scheme to represent a SynergyNet project, and we have in this project the roadmap. Here we have prostate cancer, and the background of this cancer is represented with the most common type of cancer incident for mortality in 2020 in each cancer. In the panel are prostate cancer incidents, up or down, we have B, and the prostate cancer mortality depicted in green color. So here we put in current scientific literature is confirmed that the crosstalk between laboratory medicine, and the imaging techniques, and we are represented collected two important original articles. Predictor and prognostic biomarker in neurological tumors 2024 published, On the right, we have another article, 20 received in 2023. So, but we have the decisional tree of our work. In this work, we organize a decisional work in order to define this scientific approach. We try to select our patients proposing a pirate score. This is a very interesting score because using artificial intelligence, we organize this data in a lot of data in input to define in output some parameters that to select what is a very decisional for prostatic biopsy. So, what is the aim of our work for prostate cancer? To minimize the number of biopsy samples, to maximize the probability of acquiring tissues containing the neoplastic cell. And the risk factor considered for this study are represented by age and different modifiable and non-modifiable, but the study population represented in this study was represented by 150 patients, and in this enrollment we have 50 patients operated and 37 patients selected for competence and uniformity of data. So here the study flow chart of our work, and we have the data set acquired for the people, enrolled people, and the integrated procedure which then took in account different types of data, including dynamic, contrast, enhanced magnetic resonance, ultrasound images, and information related to patient. But data was processed with convolutional neural network. And the international prostate cancer contribution for our group is considered the enrollment of patients, but the selected population of 37 are represented the real sample in which we inspiring new perspective for prostate, for a worldwide prostate cancer vision. And in this representation, we have in this slide, we show the scientific, according to scientific literature. In the present slide, we show the next convolutional architecture based on UNet paradigm design. Yes, slide.
I'd like to remind you of the time reminder, please.
Magnetic resonance and the overall graphic, which average to define the portion of damaged tissue with respect to healthy tissue, and the elaborating data. And with conclusion, I underline that machine learning leverage a sophisticated algorithms to read the value insight from extensive data set, hiding early detection, diagnosis of cancer by identifying intricate parts correlation. Before starting the screen, the system was trained to recognize certain ecological images. 3, a significant number of patient data is useful to train the system, and in the future, this system could make it possible a new signature to identify certain methods and tests to provide support to cancer prostate early diagnosis. Thanks all for all working group member and 2 university with actors of a project. Thanks.
Thank you. That's an interesting work. Appreciated the hard work. How did you establish the efficacy of your system, or how did you experiment the AI execution to get the results?
A contribution of our results in this program, for this project we try to define for different type of a neoplasm different data in input to introduce all system in a different data. We have to organize an input of data to receive in the end of the elaboration of a convolutional neural network some parameters that are considered defining the neoplasm, and it's very important to introduce some consideration.
Okay, did you use any programming or any existing system, existing software for your experiments?
Yes.
Or it's just data?
Yes, I have no a lot of data because our project consists of the elaboration of the different parameters in different type of tumors to organize and to give input to system of convolutional neural. It's very difficult for this definition of it's very difficult to use artificial intelligence, deep learning, machine learning, and we have to give an alert to the system, and we have to organize the intelligence of the system, because is not possible. I show Vitruvian Man because artificial intelligence is important to collect data, but for this project funding from Campania region, now we are collecting the data to define this system and the elaboration of new signature for early diagnosis for different neoplasms.
Right, thank you. Which country you are from?
Yeah, I am from Napoli, Italy, from Naples.
Napoli. Yeah.
Yes, fundings are from Campania region, and
right.
for this project we work. Member work is from 2 universities, 2 faculty
right.
of medicine, and
yeah, we have seen it. We have seen it on your presentation, right?
Okay, thank you very much.
Thank you. I think we can go to the next presenter. Thank you. Appreciated your efforts.
Yeah.
Thank you, sir. Thank you, ma'am. We'll be proceeding with the next presenter. I'd like to invite paper presenter. Just one second. Eman to present the paper titled Modeling and Capturing Malicious Behavior to Detect Android Malware. You may start.
Hi, can you hear me?
Yeah. You're audible. You may start with your presentation.
Yeah. Can you see my screen?
Yeah, it is visible.
Okay. All right. So in this presentation, I'm going to give a brief kind of overview of the cybersecurity landscape and what prompted the research that we're working on and our proposed solution. Then I'm going to describe the different, like the pipeline of our detection framework, or of our framework to detect malware. And then I'm going to show its performance on Android malware using an Android data set that's been used in the research literature. And finally, I'm going to summarize the results and contribution and talk about the future work. So I think it's safe to say that we've all noticed an increase of news articles about malware attacks in the recent few years, especially after COVID, and how they target small and medium-sized companies and even individuals due to their lack of good cybersecurity infrastructure. And of course, there's this ongoing race between hackers and cybersecurity researchers and professionals where they try to stay ahead of any new threats, cyber threats that come out. However, most antiviruses use static analysis to detect malware, which is based on a fixed signature that they generate to detect any incoming malware. However, this is weak against evolving type of threats where hackers try to modify their malware to escape detection. So our question, or our way to kind of interact with this problem is, well, is there a different way to detect malware that is not fixed or that is not static? Meaning, like, can we study the behavior of programs and find any differences between malware and benign, or like how they execute in the target system? And is that difference significant enough that we can use it reliably to detect between benign programs and malware? And so we hypothesized that there is such a difference, and even more so that similar malware will have similar ways of behaving or similar execution patterns. By similar malware, I mean malware that belongs to the same family or the same category. And so we decided to try to analyze this behavior by analyzing the relationship of native function calls, which I will explain in a future slide, and represent their behavior using graph modeling so that we can properly capture the complex relationship between these functions. And then once we generate these graphs, or what we call behavior graphs, we use deep learning methods to extract features from them and then classify them into either malware or benign. So what do we mean by program behavior? So program behavior is the sequence of actions that a program takes when it's being executed in a target system. And to do that, the operating system provides these low-level functions called native API functions that are outside of the hackers or the programmer's control, that allows the program to interact with the computer and the hardware resources like CPU and memory. When analyzing a software or a program, let's say, for example, in a sandbox environment, an isolated environment, you can actually extract a log of all of these functions that it executes in the system, and they look something like this. They seem like just normal functions with a series of variables that are usually represented in hexadecimal format. And for the purpose of this research, we say that two function calls are dependent if they share at least one non-null argument. Like, for example, when a program, let's say, wants to open a file and edit it, it will call three functions: one to open the file, and one to edit it, and then finally one to close it. And since all these files work on the same data, we say that they are dependent. Now, to analyze these log of system calls, what we do is we use a graph modeling where we represent each function with a corresponding vertex, and there is an edge between these between two vertices if the system calls are dependent. We usually restrict the calls to like a window size of 10, meaning that even if two function calls are dependent, but they're really far away from each other, we don't consider it, just to save on computational power, but without really losing in performance. Now, once we generate these behavior graphs, we would like to use deep learning to be able to analyze them and classify them. However, regular neural networks, they don't accept graph structures as input, but more like they take one by n dimensional input vectors, which makes it complicated for us to use deep learning. However, there are these methods called graph representation learning, and they work in the following. So we need a vector like this to use or as an input for a neural network. And this representation learning will automatically learn how to generate from a given graph, they will learn how to generate this feature vector representation. And there's usually two cases. There's node to vector and there's graph to vector. In our case, we focus on case number 2, which is graph to vector, where we want to represent the whole behavior graph of a sample of a program into a feature vector. And the training of these models goes like this. So first we have an input graph, and we have the graph embedded layer, which is a neural network that is trainable, and it will learn how to generate a good feature representation of the graph. And then that vector will be fed into another neural network for downstream classification. And this doesn't have to be a neural network. It can be then a regular machine learning, like random forest, for example. And then during testing, we already have now a trained graph embedded layer and a trait classification output. And so the testing data will go through this pipeline again. However, now this graph embedding layer is already trained to generate a feature representation that captures the inherent characteristic of the graphs for the purpose of this downstream classification here. So to kind of summarize, our malware detection framework looks like this. So it takes an APK sample, an Android package sample, an Android application as input. It will analyze the API call logs from the execution of that sample, and then model it into a behavior graph. And then we split the data into training and testing. The training data will be used to train the graph embedding layers and the output layers, and that will return a trained model that we will then feed into the testing data to validate and test the performance of our model for malware detection. To validate the performance of this framework, we use the mal-Android 2020 dataset, which is a widely used dataset in the Android detection research literature. And it has 5 different categories: adware, banking, SMS, riskware, and benign. And the goal is usually malware detection and classification. So these are the results achieved by our malware detection framework on this dataset. We tried different representation learning algorithms, namely graph embedding methods and graph neural network methods. And the best performing one achieved an accuracy of 99.25%. And this is the confusion matrix obtained with this algorithm. Here I'm showing the comparative analysis of the state-of-the-art research in Android malware detection, and all these research papers. So they use different types of features and different types of deep learning models, and they all work on the same data set. And that's why we were able to do a comparative analysis. And our research performed as well as if not a little bit better than the current state of the art. So to conclude, so this malware detection framework is able to achieve high accuracy for Android malware detection. And it has a couple clear applications. Like, for example, Android users can test if an application that they download from the website is a malware or not. And Android application publishers, like the Google Store, for example, but more, let's say, independent websites, can test the safety of any submitted application before they they let other users download it, and that way it will stop the spread of malware from the source. For future work, we're thinking about combining manual feature engineering and representation learning to analyze the malware behavior graph, and in order to increase the performance of our framework. And we will also test the performance of our detection framework on PC, malware, and software, since the graph modeling method works for both types of program, not just Android. And that's it. Thank you very much for your attention.
That sounds like good work. Is it only for Android, or it's just the application for the Android?
For now, due to the availability, dataset availability, we tested it on Android. However, the framework can be used for both PC and Android as well. And we're currently testing it on Windows malware, and we're writing a paper on it currently. So yes, it can be used for both.
Good, good. That would be great. You can extend to the other applications also. Thank you very much. Then I think we can go to the next presenter if there are no questions.
Thank you, sir. We'll be proceeding with the next presenter. I'd like to invite Eduardo to present the paper titled Prediction of Customer Underwriting of Policies in Banking Institutions Through Machine Learning. You may start with your presentation, sir. Sir Eduardo, if you're here, then you may start with the presentation. So Stephen, it seems he's not here, then we can move ahead with our next presenter. Our next presenter, Louis, to present the paper titled Using Feedback Matching Algorithm in Time Series Future Values Production.
Good afternoon. Hello, everybody. Let me share my screen, please.
Sure, sir.
Okay, the screen is clear now, please.
Yeah,
My screen is clear.
visible. Please go ahead. It is visible.
Okay, thank you. Our presentation today about the new algorithm using feedback matching algorithm in time series for future values prediction. Actually, the time series is very important, and the time series just consists of sequence of observation ordered chronologically, where subsequent observation are depend on previous one. Values follow each other and depend on each one. Time series appear in many applications like engineering, sociology, medicine, public health, and economics. Studying time series is very important and help acquiring precise depiction of process, creating models for prediction, and leveraging the heuristical behavior for the forecasting for the future. This is important. Future forecasting for the values. Forecasting and prediction future behavior of time series is crucial for planning and control operations in various fields. Many articles discuss that techniques for burning and the unnecessary parameters, especially in the context of regression models, and research have extended the proposed technique to case of time series. This research aims to develop natural computer representation and modeling for time series to predict feature values based on the heuristical data and feedback matching. The research question and the hypothesis. The research question, we have two questions. How can time series be naturally represented without complex mathematical abstraction using computer model? If there are a simple prediction algorithm that can be used, the natural computer formula representation to find future value in the time series. The hypothesis of our research is the feedback matching algorithm can effectively express time series through a cohesive formula and accurately forecast its future values. The research focused on literature review, checking what exists forecasting methods to determine the future values for the time series, and the approach is to find from that literature reviews the suitable method for modeling and prediction time series, inductive reasoning to examine and test the feedback matching algorithm in time series prediction, showing that the truth of conclusion based on the truth of the examined facts. The criteria of article depend on the literature review, searching on the literature review, and comparing the invented algorithm with the existing works. We have many methods in time series, traditional method and more modern methods, like using the deep AI, neural networks, deep neural networks. The criteria for article selection involve the use of selection of literature review, of course, modern time series modeling, and its impact on future value prediction studies. Case studies, for example, this is examples of a number of studies that we already discuss in our, or use it as literature review in our research, in our article. Post-sunrise solar irradiation prediction using infinite dimensional lag coordinates, formulation of UIP through nonlinear time series forecasting, various methodologies employed for prediction economic growth, time series forecasting model using artificial network enhancement by PSO. And we have also some studies for time series, like estimation of PM2.5 concentration using the least segment terminal neural networks, composite time series forecasting using higher order fuzzy time series theory, examination of Muscat stock market index 30 for stock price direction evaluation, consumer research or on function estimation and future nervous system application. Now, the time series method, most of the time series method depend on two main methods. The traditional methods based on the trend, estimating the trend of the time series, and the forecasting will be depend on that trend. Methods for estimating general trends, moving average methods, sequential averaging of data point, method for least square trend calculation using linear regression, and so on. And we have the emergence of method, which is use the AI, use the neural network, deep learning. Deep neural networks are surprising traditional models into various application. Deep learning for time series forecasting required comprehensive evaluation and comparison of architectures. Most of these two type of methods, these two categories of methods, have the same drawbacks. It just converts the time series from its original presentation, from its natural representation, into artificial representation, into mathematical representation, both the traditional method and the deep learning method, the neural network methods. So series observation may not align with the trend line, loss of natural series form, resulting in inaccurate prediction, need for further research to improve accuracy and applicability of forecasting method, emphasize on addressing limitation and exploring alternative approaches. In this research, we try to redefining the time series, how to understand the time series in more simplest way and more professional method. So we use the traditional approach, express time series using mathematical formula. This is the traditional approaches, even the deep learning. Formula not precisely aligned. Our proposal is to view the time series as a sequence of continuous observation, over time. Just keep the same values, the same sequence values, but keep it in an algorithmic way. Save it in an algorithmic way. So we keep the same graphical representation to reflect the model accuracy and presenting data. Comparison between, of course, we should compare between the natural and artificial views of the, we use the gold prices as an example for impacting, our data sets depend on the gold prices data to compare between the traditional method and the research method, the proposed method, the proposal method. Natural approach to time series prediction. This method, which we consider on it, our research concern it is to represent the time series on a natural approach for prediction. Importance of natural, very important to keep the natural, what we can say, the natural pattern of the time series. It's very, very important to save it, not keep it inside the neural network weights and the mathematical values, or even with the mathematical, for example, the linear regression or regression in general, any type of regression, we just convert the natural time series into mathematical formulas and values. In this research, we will try to keep the natural view for the time series. So, okay, if we keep the natural view, how we can predict the values, how we can calculate the future values. So we should put a predictive method. We utilize the concept of the succession of events principle. Usually the events, even with not the same value exact values, but the time series repeated itself like anything at the history. It just repeated, but with different faces, with different stories, with different scenarios. But usually the tone is the same. The tone is the same. We concentrate on the tone of the time series and we use it to enable prediction without playing on artificial mathematical formulation, just to concern on the same signature of the time series to get the future value. Offers a new presentation on time series analysis and forecasting. Future values, as we said, depend on the past patterns. So we can just use the past pattern to predict or forecast the future values. The algorithm for the forecasting, the feedback matching algorithm, is very easy. Just calculate the slope between adjacent points, sequence of adjacent points, and determine the Euclidean distance between the last appearance of the time series and the possible appearances. We just get the last pattern of the time series, for example, for 1 or 2 years, and try to match that pattern with the all data, with the all saved data, for example, for 20, 30, 50, 100 years, as much as we have data, so we just compare that pattern, that part of the time series, regardless the value, just compare the patterns, not the values, so that we use the slope and we use the Euclidean distance. We don't compare the values. For example, the gold price during 5 years, it come in a specific pattern. It come, for example, between 1,500 it reached now about 2,000, maybe $50 and so on. So the patterns change. Maybe we depend on monthly data, not of course not daily. We get the month average. So with 2 years, we have, yes.
I'm really sorry to disturb you, but I'd like to remind you of the time limit.
Okay, so we just compare that pattern with the old data starting from 100 year, and we compare which pattern is more similar for that pattern, and we can use the next values for that pattern as a prediction for the future. We test that method, test that algorithm with 12 in 12 data sets, and with actually 7 methods. Most of them are neural network methods, and we compare that 12 methods together with the feedback matching algorithm, and this is the results depend on the weighted percentage absolute error between them. This is the values, and this is the average for the weighted average percentage error, and we can see the feedback match algorithm has very good percentage when we compare with the other methods. This is this is depend on the gold price, this figure, and show the different data sets and also the different algorithms and our algorithm. As a conclusion, we just invent a new method for comparing or present for the presentation of the time series and also for finding the future. And it is good, but at the end, our method not to produce a mathematical formula. This is the drawbacks of our method. But even that drawbacks, maybe it's an advantage when we compare it with the other method. Thank you. Thank you very much. Thank you. And please, if you have any question, please.
So, Stephen, would you like to ask any question?
Yeah, I'm good. If there is anyone from the participants, that would be good. I've been doing that. So if you have any questions. Thank you.
Thank you. Thank you.
Thank you. I'd once again like to ask for Sir Eduardo, paper presenter. If you're ready, then you can start your presentation. If you're here with us.
So sorry, how many presentations left for the day?
Sir, only one is left, but it seems that the paper presenter is absent.
Okay.
That brings us to the end. I sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 9th version and the previous 8 versions of the conference. We will be happy to have you in the 10th version in 2025. All the presenters will be getting their digital certificates through email within 2 working days. Further, all the papers have been forwarded to the Springer. The publication will be live within 6 months, so kindly cooperate with the team of ICICT 2024. I also would like to thank our session chair, Dr. James Stephen Maka, for chairing the session. A token of appreciation on behalf of the team towards you, sir. Thank you. Thank you for chairing the session.
Thank you to all. Thank you.
Before we end, I'd like to request everyone to turn on the cameras for a quick snapshot of the virtual conference. Thank you, everyone.